Yes, now I can introduce myself because I have the next presentation. My name is Florian Freund. I'm a PhD student at the University of Hagen, and I will tell you something about our survey. Let's share my screen. Okay, I hope my screen should be visible now. I will tell you something about our survey to understand the challenges of machine learning experts using named entity recognition tools. First, some brief introduction. Then I will tell you something about the state of the art in science and technology. Then I'll present the expert survey modeling, then the evaluation, and at the end, a conclusion. So first, some introduction. Named entity recognition tools originated in the early 1990s and have evolved significantly since then. And they offer both library and framework options. NAR is a part of natural language processing and is essential to convert unstructured text into structured data. And this is, for instance, crucial in healthcare to address information overload. As an example, in my research area, the information overload complicates the development of clinical practice guidelines in the medical research area, because to develop such clinical practice guidelines, evidence-based medicine is used, and to search for this evidences, the medical experts rely on unstructured text, such as clinical reports. And by unstructuring this text, named entity recognition aids in managing information overload in the medical field. And after structuring the text, these structured data supports then information retrieval to form the evidence base for clinical practice guidelines, and this clinical practice guidelines reduce patients' risk and aid in clinical decision making. Recently machine learning-based methods are pivotal for named entity recognition, and there is an increasing number of tools which are challenging the users to stay up to date with them. And it is challenging for users to stay up to date on the latest developments in this field. So the research goal of our survey is to explore the challenges machine learning experts face when they compare and select named entity recognition tools. And the findings will assist non-experts in making informed decisions when choosing named entity recognition tools. The research is motivated by related research projects. There is the Artificial Intelligence for Hospitals, Healthcare and Humanity, AI4H3, and embedded in this project, cloud-based information extraction. And those initiatives underscore the need for transparent and efficient artificial intelligence decision-making processes. And they are aiming to streamline this, the use of medical AI and medical AI modules through a centralized hub architecture. Despite advances, machine learning-based named entity recognition systems remain underutilized because they rely on technical expertise and resource and intensive setups. And there comes the project, which is my primary project, Framework Independent Toolkit for Named Entity Recognition, fit for NAR, and it aims to empower medical experts with a user-friendly AI analysis capabilities and showcases potential path to a greater adoption of named entity recognition. The challenges which are presented by the dynamic NAR research in the recent years for domain experts include They struggle to compare NER tools and to identify suitable NLP features and entity relations for their specific task. They need to select the most effective NER solution for their specific tasks, and they have limited computational resources and technical knowledge, which hinders domain experts for independently training and leveraging high quality NER models. Yeah, so the research questions are how to machine learning experts evaluate NER tools and which criteria are most important to them, and what primary challenges to ML experts face when selecting a suitable named entity recognition tool. Now I will go a little bit deeper into the state of the art. So first, named entity recognition again. NER is a technique to extract named entities. So in the standard entities are people, places, or organizations which are extracted from text. In the medical environment, there would be specific entities like, I don't know, treatments, illnesses, or something like that. So NER is essential in applications like information retrieval, question answering, machine translation, social media analysis, and in the medical domain. And here it is used for clinical decision support systems and electronic health record mining. NER systems can be developed with rule-based methods, machine learning-based methods, and hybrid approaches. But in the last years, machine learning-based methods with large data sets and deep learning improved the NER performance significantly. They learn named entity detection from annotated data and process unstructured natural language text. The advances in the last years were pre-trained models like BERT-GPT or Roberta, and ongoing NER research develops innovative tools to address different challenges and use cases, which emphasizes it is required to select the best suited tool for a specific task. So there's a remaining challenge here. We want to gain insight how NER tools comparisons are conducted in practice and identify the challenges and factors that influence the decision-making process. Then another related topic is the topic cloud computing, because training machine learning models requires a huge amount of compute resources, and the cloud is maybe a solution for that, because you can dynamically book such resources and use them. AWS, Amazon Web Services, pioneered the cloud computing in the early 2000s. And offered scalable resources on demand. And cloud computing has transformed the AI development by efficiently supporting model creation, training, and deployment. In the recent years, there are various abstraction levels, such as infrastructure as a service, platform as a service, or software as a service. And there are machine learning cloud platforms which adapt to performance demands with advanced data processing, training, and deployment options. The big providers like AWS, Azure, and Google Cloud Platform all offer various named natural language processing and named entity recognition services with pre-built models and APIs for a seamless AI integration. But despite those benefits, there are privacy and ethical challenges, especially in sensitive fields such as healthcare, and machine learning professionals which choose cloud services for their natural language processing tasks must consider scalability, cost, security, and ethics when choosing cloud solutions. So we also want to know the key factors machine learning professionals consider when deciding whether to use cloud-based resources. Lastly, I want to mention some related studies here in the state of the art. There were various studies comparing natural language processing tools. First, Pinto. He evaluated NLP tools on formal and social media texts, and also named entity recognition. And they noted it is challenge to select the right tool, and the choice may depend on several aspects, including the kind and source of the text. Omran performed a systematic analysis in 2017 and emphasized also the importance of choosing the right library. One demonstrate that any NER system performance is depend on the corpus, and that combining tools can enhance the outcome. Weying conducted a benchmarking study in 2019 and highlighted the need to carefully select an NLP library. Schmidt also highlighted the challenges in selecting tools and pointed out the difficulty in comparing them. Abdul-Maki conducted a comparative study for Arabic texts and also found that the combination of tools may improve performance. Hemmje examined top datasets tools, and they found that deep learning excels the feature engineering, and it is a complex area, and also the combination of models can yield superior results. The last study I want to mention is Hemmje, which surveyed Microsoft engineers on AI and machine learning. And for them, it is an important result that training and support for users which are inexperienced with AI could reduce the learning curve. So our remaining challenge here is that we want to investigate the challenges faced by machine learning experts in comparing NER tools to select appropriate solution. How have we done this? First, we wanted to address our research questions systematically, and we wanted to conduct an expert survey to obtain expert insights, and we used the Kasunicâ model to survey machine learning experts in NER for that. This model includes 7 stages for conducting surveys effectively, and therefore ensures structured and informative data collection. Here are the 7 steps. First, the objectives were derived from our research questions. The first objective is to identify criteria used by machine learning experts for evaluating NER tools, ranking their importance. And the second one is to examine major challenges machine learning experts face in choosing suitable NER tools. Our target audience should be experts with more than 3 years of experience in machine learning, NLP, or NER, or alternatively with a relevant PhD. A sampling plan is not so important for us because we focus on expert input and we don't want to generalize our results. Participation was voluntary, and we evaluated the expertise of the participants through collected background information. Our questionnaire was developed and structured into 3 sections. First, some demographic and background data was assessed, and then the main part was experience with NER tools, evaluation of tools and frameworks to address the remaining challenges and objectives. And finally, we had some questions about the survey experience and additional insights. We pilot tested the survey with 3 experts with more than 5 years of experience, and found that initial versions could not capture key tool selection factors and had problems with multi-tool experience when participants have more than 1 tool used. We wanted to assess specifically good results for the specific tools. And we did revisions where we reduced questions tool and improved the clarity with the examples. The survey was distributed in August 2024. We sent the questionnaires to 27 namely known experts in machine learning and natural language processing, and email distribution list at the Fraunhofer Gesellschaft in Germany with over 60 members working on the topic of natural language processing. We got 23 responses, which is a response rate of 26% until October, which exceeds the response rate of similar surveys. The analysis of the results is shown on the next slides. So let's go to the results. First, the demographics. Our participants aged in the majority between 25 and 34 years old and 35 to 44 years. We had a high educational level, the predominantly doctorates or master degrees, and the most participants graduated in computer science. But we also had some participants from other disciplines like economics or history. The experience with named entity recognition wasn't so high we expected. Half of the participants had less than 1 year of experience in named entity recognition, but the majority rated their experience as average or good. And with the given high educational level, we found that the level was high enough to gather meaningful insights. We have assessed the roles and domains of the participants in NER projects, and we had a diverse representation of roles with software developers, data scientists, machine learning engineers, and mostly software developers. And the NER project domains was most commonly natural language processing and speech recognition, but also a significant presence in healthcare projects. We asked the participants about their experience with NER frameworks, and most frequently they are using Spatie, Hugging Face Transformers, and also OpenAI's GPT-4. When we assess their levels of experience in those with those frameworks, we found that Hugging Face Transformers and OpenAI GPT-4 achieved the highest ratings with for ease of use and effectiveness. So this was these were the best rated tools. And next we asked them about their selection criteria. And first on the right, you can see the various selection criteria, and the performance is the most important factor by far. And for cloud-based tools, licensing and cost are particularly relevant. But you also can see that there wasn't any criteria which which is not important. Every criteria was mentioned at least once as very important or important, and so every criteria may be relevant depending on the project. On the left, you can see a table where we compared cloud-based tools versus local tools, and wanted to see where are the differences. And locally installed Apple systems prioritize documentation and support, while cloud-based tools focus on user interface and ease of use. The hindrance criteria when you decided when they decide against NER tool, we saw that criteria were rarely considered very hindering. In general, time and effort to learn new frameworks was the most hindering, followed by performance issues, which aligns to the high rates of performance in the last slide. Comparing a cloud versus local tools, we see that cost is the most important thing for cloud services, and for locally installable tools, there are issues with time and effort in learning new frameworks. We also had open questions in the survey. We asked people if they were using other NER tools, and one of the participants we want to highlight here noted the use of self-hosted open source large language models. We assume he downloads large language models, I don't know, from Hugging Face or so, from the internet, and uses them for local NER applications. And he rated this his expertise as very high here. He also rated every selection criteria as very important, except customization and integration, which is not important, and is interesting for open source and local used large language models. The hindrance criteria he mentioned very hindering for integration into existing applications, and cost and performance was rated with the moderately hindering and all other with not hindering. So we assume there were high expectations for NER tools, which led to local open source LLM usage, but there is some ambiguity because he stated that there are high integration and cost ratings, and maybe he misinterpreted here or related to other solutions. But we think that open source large language models is a relevant technology for named entity recognition. So finally, we asked the participants about their survey experience, and they were overwhelmingly positive feedback. One participant noted in an open question at the end that the questions were occasionally too detailed. Now, some threats to validity. We had 23 participants, which may limit the generalizability of the results, but our service aimed to inform on relevant criteria for comparing and selecting NER tools and framework is reached, and thus the limited generalizability poses a minor risk for us. The predominant computer science background among the participants could introduce some bias, and therefore their insights may not fully represent other disciplines, and so further future surveys could include more diverse domain experts. The participants noted that some questions were too detailed, which possibly may affect the completion rate and accuracy. And while we valued the specificity in future surveys, the level of detail could be reassessed critically. The mentioned threats have been adequately considered in interpreting the results, and the remaining risk to the findings of the survey are assessed as low. So the conclusion, we conducted an expert survey and highlighted key selection criteria for NER tools utilizing Kasunicâ survey research process. Our research objective 1 to identify relevant selection criteria for NER tools and frameworks can be answered as follows. Performance is a crucial criterion, but all specified selection criteria were regarded important or very important at least once. So when we want to build a system which supports selecting and comparing NER tools and frameworks, we need a flexible system which aims to accommodate diverse criteria and performance needs. Research objective 2 was to distinguish between cloud-based services and locally installed tools. And there we can state that cloud-based services prioritize cost and user friendliness, and locally installed systems should minimize the user adoption effort. Open source, locally installed language models are relevant and should be considered in future developments. And future work should tailor results to domain expert needs, enhancing NER utilization in clinical practice guideline development. So this was my talk. Thank you for your audience.